and ester. Look at this general point. Do you have that written on there? If you don't, write it right now next to ester. A lot of the ones that I don't have written next to yours, I'm reminding you about because I didn't write it on there because it was hard for me to write it with just a word processor. Okay, I'd have to put the double bond or whatever. It's a pain in the neck. So you just write it in yourself. Now, first of all, the properties of an ester. Esters are one of the first things you'll notice about the ones we're going to make is that they smell. They smell a particular way. They have very distinct smells, and they're usually good smells. Okay, so in other words, they don't smell like you guys. They have fruity or minty smells that you will actually be able to identify when we make 5 of them in lab on, well, one of the, there'll be a mint. Although we use spearmint back when we were talking about enantiomers and diastereomers. We will not make spearmint this time, but we will make one of a mint. Okay, and we'll also make several fruits. Okay, so that's the first thing you'll notice. By the way, not all esters have that smell, but the smaller, lower molecular weight ones generally do have a very characteristic, distinct, and usually pleasant odor. And they are made naturally in plants and fruits. You know, like that. They put them in there, and they have this pleasant odor, partly so you'll eat them. Why would the plant want you to eat the apple or the fruit or whatever? Yeah, so you'll eat the seeds and spread them throughout the woods, like a bear.
Birds.
And a bird. Yeah, good. Okay, all right. Second thing about them, though, is they are the organic equivalent of an inorganic salt. Now, here's another. I said we're going to have a couple of things to review in Chem 1, from Chem 1 today. This is the other thing. We talked a little while ago about acids. What makes something an acid? Hydrogen ions being donated, or hydronium ions being made. What makes something a salt? Who can remember how we made salts? What did you react together to get a salt? An acid and a base. Yeah, absolutely. In the inorganic world, an acid plus a base, write this down. And you have, it started for me there, I believe, right? Inorganic world. An acid plus a base gives you 2 things. Gives me 2 things. What are they? Salt and water. Exactly. Well, yeah, salt mixed with water. Sure. Salt water. All right? And if you don't believe me, and if you don't remember that, I'm sure you probably don't, let's take our most famous acid. Who is he? Hydrochloric acid, HCl, correct? Who's our most famous base? We don't use them as much, but it was sodium hydroxide. I've used them a couple times even this year. Sodium hydroxide, NaOH. If I take HCl and NaOH, I get NaCl and H2O. Isn't that amazing? Well, it shouldn't be amazing. You should have remembered that even from last year. So you have your Cl from your Cl from your acid, and you have your OH from your base, right? Your Cl from your acid, your OH from the base. They get together, right? Oh, whoa, sorry. That was dumb. Cl from the acid, I was trying to use colors and think at the same time. I can't do that. Na from the base, you get the Na and the Cl together, and you get NaCl. Okay? Meanwhile, you've got your H from your acid and the OH from the base, and they get together and make the water, right? You don't have to draw those lines. I'm just showing you what happens, right? And by the way, this is the key, guys. Let's be erase this. In Chem 1, we did a ton of acid-base reactions, right? Do I have to have NaOH? No, I could have KOH. I could have CaOH2. And that would only change, wouldn't change much. It would change how you balanced it, but it wouldn't change much of anything else. It would still give you, if this was HCl, it could be H2SO4. It could be H3PO5. It could be anything, as long as it's an acid. This H and this OH will get together. This negative ion and that positive ion would get together and do that one. So you'd have potassium sulfate and water again. Okay? So you remember doing that, right? Sure. All right. Well, here's where we're going to relate. I said that was a little bit of a review. Here's where we're relating this to organic. What is the organic equivalent of this? your carboxylic acid and your alcohol. Okay, I didn't want that all to come up at once. The carboxylic acid is clearly the acid part. But why is the alcohol act like the base in this case? What does the alcohol have? Huh? OH. What makes a base basic? The OH. So, your carboxylic acid and your alcohol give you your ester and water. Yay. And there was much rejoicing. All right. So, let me draw the general formula for this guy, which I don't think I have down here. Let me just double check. No. Okay. So, a specific formula for this, although I'm using general formulas. R, C, double bond, O, OH. That's your carboxylic acid, right? Plus, and I'll make him in a different color, although it doesn't really matter. R, OH, yields. Well, what's going to happen? What's nice about this reaction, it allows me to join together long carbon chains, okay, from two separate sources. Up till now, for the most part, what have we been doing? Well, we'll take an alkane and we'll make it into an alkene. Or we'll take an alkane and we'll add chlorine onto it. We'll take an alkene and we'll make it into an alcohol by adding an OH on it. We'll take an alcohol and turn it into a carboxylic acid. Just replacing where the OH was, now I got a carboxylic acid group. Not really changing fundamentally a whole lot about the compound. If I had butane over there, I probably got butane over here. I just happen to have an OH on it now. Or I have a carboxylic acid or an alkene or whatever. This is different. I'm actually going to link together. This carbon could be 1, 2, 3, 4, 10, 12, 15 long. This carbon could be 1, 2, 3, 4, 10, 12, 15 long. And I'm going to link them together this way, through this little ester linkage. That and see it? So this R from here hooks up to that O over there, and now I'm going to have C, that, C, and on the other side of the O, carbons, as many as I want, branching, whatever, okay? Plus water. Don't forget the water. Oh, and one other thing, I forgot to mention in the other class, I'm going to have to make sure I say it in the future. It's on your paper, I believe, and it's definitely on the paper I'm about to give you in a few minutes for next period. This is a reversible reaction. Goes both ways. Does it have a reversible sign there for you? For the general formula? Yeah. Good. I thought it did. This is a reversible reaction. And what you'll do in a reversible reaction, we're going to learn this in equilibrium, there's ways to drive it one direction or another. Okay, and we're going to do that in the lab on Friday probably. All right? We want to make sure it's going this way. We're going to take our alcohol and our carboxylic acid, react them together to get our ester. All right, well, we have to learn how to write these specifically, and we have to learn how to name them as well. I'm actually going to do things a little differently. Normally I would do, this is a naming system. And then I would say, now, here, let's do this. I'm going to actually do the reaction first, and show you where they come from, because the naming system is very much dependent on who came from where. All right, so let's do that. Preparation. How do we make esters? All right, again, you have, oh, that's amazing. Keep doing that. You have two little bonds there, two little bonds there. Okay, and something like that. By the way, if you're wondering about this prime here, that just means it's a different R group. It may be the same, it may be a different number of carbons. All right, so this R group joins up with that R group through this ester. Okay. All right. Let's do an example. You ready? Copy this guy down. If I gave you that, and again, it's a reversible arrow here. If I gave you that, And by the way, 2 arrows means it's an equilibrium reaction that can go both ways. And it will go both ways. What's that? All right? Can you finish that guy and name everybody in here? Okay? Why don't you try it? Because I'm going to rewrite it. I actually realize I want to leave a little bit more. I'm going to run out of room over there. You try it on your own. See if you can finish it and name everybody. And then I'll do it for you. How would you link those guys together? Did you draw that? I hope. Does that make sense? See why it makes sense? You know, you have this guy who's got 4 carbons long, combining with this guy here. Okay, and there he is. This guy and that guy. This guy and that guy. You combine there. And it's all balanced for you. It comes out balanced. Can you name everybody? I hope. You can name that guy. What's he? Butanoic acid. And this guy would be methanol. You've seen both of those before in examples. And that makes this guy, that's the crazy part. That's why I saved him for naming. It's going to give you the system, the actual, steps to name it. But that's why I saved him for last. What would I call this guy? This guy will be called methyl butanoate. Methyl butanoate. Okay? Now, why? What are the rules to do this? Well, let me say them to you first, then you'll write them down underneath nomenclature. Here's the basic rules. You're going to name the guy that came from the alcohol first. That's this guy here. Then you'll name the guy that came from the carboxylic acid. That's this guy here. Second. So methyl came from the alcohol, methyl. This guy came from the carboxylic acid, bute. And then you add OA to E, butane O8, methyl butanoate. Right? So, let's write that down for nomenclature. Step 1. Name the alkyl group. Notice I didn't say name the alkane. It wasn't methane butanoate. It was methyl butanoate. You treat them almost like an alkyl group on to anything else. Methyl butanoate. Alkyl group first. That's the methyl part. Right? Got it? And if I had a methyl coming off of a regular chain like this, that would be methyl propane. 2-methyl propane. Okay. Second, you name the alkane, not the alkyl group, but the alkane that came from the acid last. And then finally, you add what suffix? O8-TE. What's the suffix? O8? What am I supposed to wait for? Oh wait. Oh wait. Oh wait. Oh wait. What's the suffix name? Oh wait. Oh wait. Oh wait. Oh wait. Okay. Get it?
It's too early for jokes and stuff.
Yeah. All right, and that's basically how you do it. Now we're going to do 2 examples. Oh, not there. We'll do 2 examples. We'll do 2 examples underneath that. You obviously you have room for 2 examples there, right? Let's do that. Let's do 1. Okay. Try this guy. All right, try that guy. Now, I know I will get mistakes. There are two biggies I will get on this. So that's why I want everyone to have an answer for this. Because you will make a mistake. If you just copy down the answer, you will not know why it looks like it does. And you'll just you won't even know what mistake you were going to make. So answer it. Put an answer down. Come on. Put an answer down. Waiting until everyone has an answer down. Including Olivia. I want mistakes. It's okay to make a mistake. That's the point. There are two big mistakes that you'll see here. Two big mistakes. And everybody should have something written down. Otherwise, it's not going to mean anything. A name. I need a name. I don't want a reaction. I want a name. You're not doing a reaction. That's the answer. This is what you made. What's the name of that? Okay, let's go over the first mistake. And probably the most common. Many people, don't write this down, will call this ethyl propanoate. I'll bet most people called it ethyl propanoate. Because you simply looked at the previous two examples, and I named the guy on the right first and the guy on the left. Now, did I ever say the words right or left? I said who came from the alcohol and who came from the acid. How will you know which guy came from the alcohol, which guy came from the acid? How will you know that? What do you think is the dead giveaway to that, people?
Where the O is.
Where the double bonded O is. Must have been from the what?
The acid.
The acid. So I have to call this guy. This came from the alcohol. By the way, I forgot my little brush. This guy is propyl. Propyl gets named first. And here's your second mistake. Many people don't include this carbon as part of the name. And they'll call that propyl methanoate. They call it a meth. When actually it's 2 carbons long. This is ethanoate. So if you had down propyl ethanoate, you were doing it correctly. But my guess is that's the minority. Most people were not looking at that. Okay? They were thinking they call it probably, because right, left. That's how we did the last two. That's how you should be doing this one. But it's not about right or left or right. Last one, quickly. What's this guy? Quickly. Bells in the ring. What's that guy's name? Everybody should be able to do this one very quickly. And I'm going to hit stop on the thing. Ethyl methanoate. Good. Ethyl methanoate. And you can take a break.
Woo! Done.